All right, so the next thing that we have is controlling your through traffic. You've seen how to control the through traffic stuff. Right, so generally you don't use ACL to control your through traffic. You normally use your, services, right? And you all know that, by default, only ICMP is allowed on the interfaces as a through traffic, because of which you can ping the firewall ports, right, from anywhere. So ICMP, all the services are allowed. So write that default only ICMP is allowed as to traffic on the FW interfaces. So whether it's echo request coming to the port, whether it's echo reply coming to the port, everything of ICMP is allowed. Okay. So if you want to control ICMP, that's important part. You generally don't want to control ICMP on the inside or on the DMZs, right? 1 second. So generally you don't want to control ICMPs on the DMZs or on the inside, because they are the trusted ports. So you want to control ICMP on the outside ports. So what you do is, you don't want any outside people to test their connectivity with your firewall outside interface IP address, right? So you don't want to allow echo request. So if inbound you receive incoming echo request on the firewall ports, you want to block it. But on the other hand, from the firewall, if you are sending echo request out, just basically type 8 code 0, right? And if you want to get an echo reply, that should be allowed, which is basically type 0 and code 0. So if the firewall is trying to check the connectivity to somewhere outside devices and tries to get the replies from them, that should be allowed. But no incoming echo request should be allowed from anybody on the outside interface. So that is the major objective that you have to achieve with your ICMP. And how do you control that? So what you do is, you say default only ICMP is allowed as to traffic on the firewall ports. If we want to control ICMP, we normally do it using services. So there is a syntax. I want to tell you that. So basically, you call the service name first. That means you're calling ICMP at the service name. You take an action, whether you're going to permit the ICMP or deny the ICMP. You define the source network. Then you define the type. So what type of ICMP service that you want to allow or permit, and then you define the interface. Right? You define the interface. Okay. So now what will happen is this. Let us say you want to control ICMP on the outside interface, that as I've told you. So let's say a few tasks I gave you for the through traffic. So first one, say it is, I'm going to block all ICMP echo request packets not to reach the firewall outside interface except say R2. Right? So I'm going to block all ICMP echo request packet not to arrive on my firewall outside port, but R2 is allowed to ping me. So R2, this guy can send echo request to my firewall port because he's my ISP. He wants to test connectivity with me. That's fine. I just allow only this particular IP address of R2. Other than that, everything else is blocked. So from the firewall, ICMP echo request packets are allowed to reach any outside network and must receive the echo reply. So if from the firewall, if you are trying to send ICMP echo request packet anywhere on the outside network, the firewall should be able to receive the echo reply, as I've told you while I was explaining the same thing. And let's say one more objective is firewall, say, should be able to reach, say, one of the DMG, say DMG4 using ICMP echo request. All right. So I want you guys to understand this. So is it clear, the task? So now I'm going to block ICMP echo request packet on the outside port apart from R2, right? Apart from R2. So what I do is, look, I call this service, that is ICMP. I permit. If I'm calling a single IP, I'll use the keyword call as host, and I'll say 192.1.20.2, that is the R2. I'm allowing only echo request. The command is echo, and I've called the interface, which is outside. So look here as for the syntax. So syntax, it is ICMP service, action is permitted, right? Source, basically this is the source, type is echo, and I'm calling this on the outside interface. Okay, so now what will happen? So if you just allow one thing over here, everything else is by default blocked. So I would just want to test you that. So let us say copy this, and I go to the ASA and paste it. Right, so I've used one ICMP service that is permitting only this R2's host. So now if you look, show run ICMP, where you can see for ICMP what all services are there. So now if you look the testing here from R2, I mean R2 can ping. So ping, which is 192.1.20.10, that is a firewall outside IP from R2, that is allowed. But if you try to ping 192.1.20.10 using some other IP, say 10.221, right? So if 10.221 wants to ping this guy, this will not be allowed. Everything else is by default block. So there is an implicit deny, like an access control list, when you are using the two services. So if you just allow on the outside port, if you write a service for ICMP that you're permitting a particular host, apart from that, if there is anything else for ICMP, it is by default blocked with implicit deny. All right. So similarly, if you try to ping with anything else, just for fun, 199.1.1.1, even this will also not work, because for that, I have no service allowed, and it is getting implicitly denied. Looking to my next stuff, from the firewall, ICMP echo request packets are allowed to reach any outside network and must receive the echo reply. So if the firewall is trying to ping anybody on the world of outside, he must receive the echo reply back. So what I'll do is again ICMP, I'm permitting the ICMP traffic. Right, source should be what now here? Any, right? Any, but I want only echo reply on the outside interface. Understandable? Yes. I'm allowing ICMP. I'm permitting ICMP traffic from any source, but I'm allowing only echo reply packets on the outside interface. Nothing else. Right? So if I just do that, copy it, go to my ASA, type in here. So now from the firewall, if I try to ping anywhere on the world of outside, say 10.221, there's an outside IP, you know that. Echo replies are coming back, allowed. 199.1.1.1, allowed. 200.1.1.1, allowed. Everything, anything is fine. But on the other hand, if I just go to R2 and try to ping to the firewall IP, which is 192.1.20.10, with source of 200.1.1.1, I mean, this will not work, because in this case, I'm sending echo request to the firewall, and this is actually not there in the services. So you have achieved that. And next thing that you have is the firewall should be able to reach the DMZ4 using your ICMP echo request. That means if this particular firewall wants to reach DMZ4, he should send ICMP echo request and get a reply. Okay, that's the whole idea. So apart from that, nothing else is allowed on that DMZ4. What I mean is this. So ICMP, you permit the host. So what I'm doing is this, look into that. So I'm permitting the echo reply from the host, right? 192.168.4.4 is my DMZ IP address of the router. I'm allowing echo reply, and it is on DMZ4 interface. So basically, this host or this source can send me echo replies on the DMZ4 interface. That means on the firewall, if I send echo request out, I'll be getting what? Echo replies back, and echo replies are allowed here. Apart from that, nothing else is allowed. So look into that. So if I go to the ASA, from the ASA, if I ping 192.168.4.4, echo request will go, echo replies will come back because of the ACL that I've allowed here. I mean, this is happening by default because the true traffic is there. 1 second, yeah, I'll tell you. So let me just copy this and paste it. I'll tell you what is the concept. So copy it, ASA. Okay. So from the ASA, if I try to ping 192.168.4.4, I'm sending echo request. I'll get back the echo reply. This is working fine as usual, right? And you know that from last time around, this R4 could also send what echo request to the firewall, right? And get an echo reply back. So at this point of time, this will not work out. So if I go to R4, from R4, if I try to ping 192.168.4.10, will this work now? It will not work. The reason is you've not allowed echo request. You just allowed only echo reply. Look. Right? So nobody on this DMZ network can ping to this DMZ4 IP address. But if the firewall wants to test connectivity with this R4 guy, we can do that. So like that, I mean, if you want to control the services using ICMPs, basically using two traffic management, you normally do that, right? So two traffic management using ICMP, this is the way you normally allow and block certain things. So like that, if you have multiple scenarios, you can take it into account. The next thing is your remote management that you normally look for. So remote management protocols, normally we use our telnet, SSH, to access the device using GUI. You can use HTTP, HTTPS, right? So those protocols normally you use for your remote management. Now, for telnet as a protocol, if you use for remote management, so telnet is basically, it is going to send the traffic in clear text method. So basically, it's a clear text method based protocol, right? It is very important thing. So if you want to enable telnet, so let us say, by default, that only two traffic, I mean, ICMP is only one that is allowed here on the ports. Apart from that, nothing else is allowed, right? So there is no other service apart from ICMP that is allowed. Now, if you want to enable telnet on the inside interface right here, so that you allow, let us say, respective, IP address or a respective admin, let us say this guy, and allow him to telnet to this particular IP, take a remote access, and then manage the firewall. As of now, it is feeling like you have the firewall, you have the console port, you are sitting right with the console port, that's your admin PC, right? And you are accessing this particular firewall. So ensure that this should not be, the factor. I mean, always direct access is not possible, right? Or the OOBM access is not possible. So what you do is you normally go with your remote management protocols like telnet, SSH, right? Or if you're using some tool, let us say ASDM. So if you use that tool to graphically manage the firewall, in that case, you need to allow HTTPS access on this particular port. Generally, on the inside port, you do that. So the administrator, whoever is there in the inside network, has got the rights to telnet, SSH, and manage the firewall using those HTTPS services. All right. So you know that apart from ICMP, nothing else is allowed. So this is very important things to understand. Okay. So going to this, telnet is a clear text method, and one more thing, very important stuff is this. Telnet actually we can enable on all the interface apart from the interface that is having a security level which is 0, right? So basically, telnet can be enabled on DMZs or inside because they are having higher security level, but telnet you cannot enable. I mean, though the command will be accepted if you want to telnet as a service on this particular outside port, but telnet commands will be accepted, but it will not be enabled because it is having security level of 0. So ensure that this is a most important thing in case of telnet. So you don't allow telnet on the outside interface, and by default, if you configure also, it will not be taken into account. All right, so it is not allowed on the interface that is having a security level 0. Right, SSH, it's recommended one. So if you want to remotely manage, the firewall, basically it's recommended to have SSH. Provide SSH access to the right network people. Recommended way, as I can say here, and we can enable SSH on any interface. So they don't have any dependency on the security level stuff like telnet has. So SSH can be enabled on any of the interface. And if you look for HTTP, I mean, one interesting fact is generally, if you want to access the GUI of the firewall using ASDM tool, you normally access using HTTPS. But what happens is if you enable HTTP by default on the firewall on the inside port, along with HTTP, HTTPS automatically gets enabled. All right. So you enable HTTP, automatically HTTPS gets enabled. That's the way the ASA is. So it is to be managed, using a tool called as ASDM. So if you want to manage the firewall using a tool that is ASDM graphically, you have to allow HTTPS or HTTP on the right interface. So for telnet, let's do some task over here. So I'm going to allow telnet access only from inside network, which is 10.11.11.0/24, and say one more is allow telnet access only from say DMZ4 network, which is 192.168.4.0/24. So basically, we're allowing telnet on two interface. One is the DMZ4 for this network. They can access using telnet, and for inside network 10.11.11.0. All right, and the way to do that is very simple. I mean, you call the service. Similarly, that's a tool traffic itself using the service. The service name is telnet, and then you talk about 10.11.11.0. That's the source network. If you write a network address, ensure that you have to give the mask and define the port. Very simple. So allowing the service telnet for the source network does. Apart from that, everybody else will be automatically denied. And likewise, you say telnet. I mean, though it is not case sensitive, I should not write actually uppercase T. It's not the recommended way when you write commands. So likewise, telnet 192.168.4.0, which is this, and this is on DMZ4. And for telnets to work, you can authenticate using a username and the password. All right. So you can also do remote authentication. I mean, using Radius and TechAxe or LDAP server. So, or you can do it using the local database. Right. So basically, what you do is for telnet, you need authentication that has to prompt with the password. Right. So you should define the password over here. Command is passwd. So don't think it's a short key of the word password. It is actually the command. So PASSWD is actually the command. And then if you do, let us say a password, say ASA12, that's a password. So if the user from this respective networks are accessing the inside interface or the DMZ interface using telnet, they'll be prompted with the password, and they should know what is the password to access it. And the password, say it is ASA123. All right. So let's go there and do that. So copy it. Go to the ASA. There you go. Done. So once you have done with this, so now you can check, show run telnet. Telnet service is enabled for the respective networks and the respective interface inside in DMZ. And if you see show run PASWD, so by default, whatever passwords you create, the operating system encrypts that using an MD5 hash. All right, so now let's say verification stuff. If I go to my R1, from R1, which is my inside network, I've allowed from 10.11 network, so I can go to R1 and test it. So telnet 10.11.11.10. I've prompted with the password, and the password is ASA123. There you go, you're inside the ASA. Now you can take care and do anything that you want remotely, right, using telnet, that's fine. Similarly, if you want to access the device from DMZ4, which I've done it, so go to the DMZ4 router, telnet 192.168.4.10. There we go. ASA123 is the password, and you are inside that. Okay. But for anywhere else, it is not allowed. So by default, you try from R3, it will not be allowed. Telnet 192.168, 3.10, no, because you didn't allow the service on DMZ3 interface. Can anyone tell me this as well? Can I telnet? One second, it's not breaking. Yeah. Can I telnet from R3 to 10.11.11.10 network? Is it possible? Telnet 10.11.11.10 from R3. Telnet is enabled on this interface on the inside port. So from R3, can I access this? We told that, to this network, people are only allowed to telnet the inside interface. That's all. Apart from that, anything else is by default blocked. So if I want to access from R3 to this, I'll be coming from 192.168.3.series IP. That is not allowed there. It will never work. All right. So this is taken care. So next is your how to talk regarding SSH. Right? How to enable SSH. Okay. One more thing. I told you that I cannot allow telnet on what interface. Your outside interface, right? Because that is having a security level 0. So if you go and say telnet, which is 192.1.20.0, 255.255.255.0, this is on the outside port. If you do that, if you see show run telnet, you can see on the outside telnet is enabled. The command is accepted, but if you see show run or show name if, that outside interface has got a security level 0, telnet doesn't work there. So if you go to R2 and try to telnet, which is 192.1.20.10, it will not work. The reason is it is allowed on an interface that is on security level 0. All right, remember these things. Okay, so going back to SSH, some task. So let's say allow SSH from inside. So this allow SSH from outside, let's say, which is 192.1.20.0 network. Right? How do you do that? Command start with SSH with a service similar source network and the port, which is inside. And likewise SSH 192.1.20.0, allowing on the outside. Now SSH to work with, it is very important that you have to define what? The username and the password. Okay, because SSH does not work only with password. So you need to define the username, say it is admin, whatever name if you want, you can define that. And password is a command, and the password say I keep it as Cisco123. So if somebody is trying to SSH on the outside port or on the inside port, right from this, IP addresses, so they should be authenticated if they enter the right username and the right password as admin and Cisco123. And for SSH to work, we need the SSH keys to encrypt and decrypt my data traffic that comes over SSH session. For that, I need to ensure that I have a domain name over here. So domain name is the command, give any name that I want because I don't have any certificate that I can take here. And then I have to generate the SSH keys. So for doing that, my command is crypto key generate RSA modulus, and basically I can define the key value over here. So normally I take 1024, right? So this will generate your SSH keys to encrypt and decrypt your SSH session traffic. And one more important command is this AAA authentication SSH console local. This is very, very important because you are actually authenticating the users, based on your local database, right? So your username and the password is right there in the ASA's local database. What else you can do is you can connect a remote radius server or an LDAP server and authenticate the users when they try to SSH or an SSH on the right ports. You can authenticate them from the external servers. In that case, it will be, you need to give the command as remote and then give the IP address of that particular server, right? So ensure that if it is local, you need to give the keyword as local, and the most important thing is it is in uppercase. Okay, this local is case sensitive, this word, and it is in uppercase. So ensure that if the users are trying to SSH from this network or from this network on the right respective interface, they should be prompted with a username password. When they type the username password, they are matched against the local database, and the keyword local is case sensitive. All right, here we go. So if I just go there and copy this stuff and go to my firewall, and I will SSH on the inside and the outside. Yes. So it took the modulus. Okay, modulus stuff. One more command which didn't took is a AAA command. So AAA authentication SSH console. See, if you give the command as local in lowercase, what happens? It says this group does not exist, right? So it should be given in the uppercase. There's a database whose name is local and this case sensitive. All right. If I see here show run SSH, I should have two networks allow for SSH. That is there right there, and I can see that the session SSH keys are generated based on the Diffie-Hellman group 1024 bits. And if I see show run domain, I should have a domain name cisco.com, and if I see show run AAA, I should see that my local database authentication is configured there. Now, so you enable SSH over here, right on the inside and right on the outside. So from the inside, it is R1, which can be allowed to reach because you allow 10, 11, 11 network. So what is the command? Can anyone tell me how to test the connectivity with SSH? Admin is the username, right? And then give the IP address. There you go. Password is Cisco123. So this is the username and this is the password, right? Here we go. This is allowed. And similarly, if you go to R2, SSH space -L, admin is the username, and 192.1.20.10. Here we go. Password is Cisco123 cloud. Apart from that, anywhere else, not allowed. Just for testing purpose, from R4, SSH space -L, admin, which is 192.168.4.10, no. All right, breaking that. Here we go. And the last thing that we have for this stuff is allowing HTTP, right? So for example, let's say that this user is an administrator and he wants to access the inside interface of my firewall using HTTP, and by using the tool called as ASDM, right? So I will power on this machine and ensure that this machine can, use this tool called as ASDM. He's the administrator, where ASDM utility is running over here, and all the way he should access, this interface of the firewall using HTTPS. All right, and make sure that he can graphically log in. So first of all, I need to allow HTTPS on the firewall on the right interface. I can do that. So 1 second. So this is http/https. So very simple command. When you say HTTP server enable on the ASA, right? I mean, this is going to enable HTTP as well as HTTPS both. And then you define which network you are going to allow for HTTP access. So basically, this user is part of 10, 20, 20 network, and the ASA knows this network using OSPF. So that's not a problem, right? So HTTP 10.20.20.0, you can enable one IP or you can give a network your call and define the port. So HTTP service is enabled, and HTTP service is enabled on the inside interface for the right source network. And you need to call this username. So username, whatever, say username is Cisco as username, and password school123. And you need to give important command is this privilege, which is privilege C15. So basically you give the users that is coming up on this particular interface with the highest privilege. That means they can access the device and they'll get the complete admin rights. And don't forget, this is also important for HTTP like SSH. The authentication of the username password is verified against the local database. So typically authentication, HTTP, command is HTTP console, local is the database name. That's all. Copy that. Going back to the ASA, enabling this. Here we go. And now I'll test the connectivity using HTTPS from this admin PC. So power this PC on. And he should be an IP address of 10.20 series network, 10.20.20 dot something. His default gateway should be the router IP. And the ASA knows this network using OSPF, so routing is not a problem. Okay. Right, so this is my PC. Let me go to the IP address properties over there, and if I see what is the IP address that this guy has currently. So if you look for the details, so already this IP address was assigned from the last class around, so it is 10.20.99. He has got a mask of /24, and his default gateway is the router. Right, simple stuff. So you can test the connectivity. I mean, this user, can ping the default gateway, and on the inside network, on the inside interface, I didn't allow any ICMP restriction. So from this user, I can actually ping my gateway, which is 10.20.20.1. The router is pinging, and from here, I can also reach 10.11.11.10 because I don't have any restriction for ping there. So I can test the connectivity to the firewall using ping. That's fine, but that's not the motto. The motto is I should reach the firewall using this tool called as ASDM. Right. So what do you do if you don't have this ASDM tool installed on your admin PC? Now what you do is you just open any browser, for example, Chrome, Mozilla, whatever. And recommendation is to use HTTPS ://10.11.11.10 is the IP address, and here we go. Certificate, because you don't have valid certificate or valid CA. Now this is the first of all, when you access this firewall, it will prompt you that install this ASDM launcher if you don't have it. Right? If you don't have it, you can install this ASDM and on your right PCs. Correct? And if you have it, then install is very simple. Just click on that, and next it will be installed. Very simple installation. Once it is installed, an icon will be there in your desktop. Double click on this particular icon. I've already installed it, so not doing it. It takes a little bit of 10 minutes time. So this icon will be there. You can just type, from the ASDM launcher, you can type the IP address of the device, and you can type the username that you want to connect. Right. So the username, say it is. What is the username I gave? Cool, right? Cool, and cool123 is the password. And once you log in there, it says continue. And it launches the window, right? That's your dashboard. So that's your device dashboard that you see. You can see the general information about the device, what is the ASA version, what's the ASDM version, what is the license that you have, right? And what are the features the license is offering. Normally you will not come to ASDM for configuration of ASAs because ASA is generally managed by using CLI. But why you will use ASDM, or where it is like mandatory to use ASDM, is when you configure this VPN wizards, basically this AnyConnect VPN, right? So it is part of a remote access VPN. So when the time comes for the VPN stuff on the last day, I'll show you, how to work with this particular stuff. So if you need to configure remote access VPN solution on ASA, you need to come to ASDM stuff and configure the AnyConnect profile from here. Other than that, you don't have really much need to work with ASA with ASDM stuff. But if you just want to hover around, you can go to configuration, you can go to interface settings, right? You can see, what are the traffic zones you have, if you have done some VXLAN configs, if it is there, interfaces. If you look at interfaces, you can see what the interface name is, or the respective IP. If you want to add, remove some IP addresses, change edit properties, you can do it from here. For example, OSPF is running over here, so routing, if you look for OSPF, you have got OSPF over here. If you want to see the interfaces that is part of OSPF, we can see that all the interfaces are part of OSPF over here, right? These are my neighbors that I have on this particular interfaces and so and so. So the whole idea is, if you want to edit some changes, you can do that from here. At the end of the day, you don't have much need, as I've told you, apart from this AnyConnect utility. You can configure this device from CLI. That is recommendation. But this is the reason, or this is the way normally you access the device using ASDM. I told you that we'll go with the NAT things a little bit today, right? And you guys can practice the stuff that I've shown here. I'll share you the files so that you can start your practice. And in the meantime, I will also teach you the basic NAT types. Like we have got different types of NAT. Not everything today, so it will catch your mind really badly. So we'll go with this couple of them: okay, dynamic NAT and static NAT. I need a